3I/ATLAS just executed a maneuver that has completely shattered every prediction we had about its trajectory. The mysterious interstellar object that was supposed to be heading toward Earth has suddenly changed course, and it's now accelerating directly toward the Sun. This isn't a slight deviation or minor course adjustment. Atlas performed what orbital mechanics specialists are calling the most aggressive trajectory change ever observed from any object in space, natural or artificial. In less than 18 hours, Atlas altered its velocity by over 8,000 miles per hour and rotated its trajectory by 47 degrees. That kind of maneuver requires thrust capabilities that dwarf anything humanity has ever built. But here's what has astronomers absolutely stunned. Atlas isn't just moving toward the Sun, it's diving toward it on a collision course that will take it deep into the solar atmosphere, far closer than any spacecraft has ever ventured. Current projections show Atlas will reach the Sun's chromosphere in approximately 12 days, plunging into regions where temperatures exceed 500,000 degrees. Natural objects don't suddenly reverse course and accelerate towards stars. Comets can't generate the thrust needed for this kind of trajectory change. What we're watching isn't astronomy anymore. It's witnessing technology in action on a scale that makes our most advanced spacecraft look like toys. Before we reveal why Atlas might be diving toward the Sun and what scientists think will happen when it arrives, smash that like button and hit subscribe, because this story just took the most unexpected and alarming turn possible. The question isn't whether ATLAS can change direction anymore, we just watched it happen. The question is, what's at the Sun that's important enough for ATLAS to risk diving into a stellar furnace? Let's break down exactly what Atlas did, because the physics of this maneuver are absolutely staggering and reveal capabilities that rewrite our understanding of what this object really is. Multiple tracking stations detected Atlas beginning its trajectory change over an 18-hour period. The maneuver started with a series of intense thrust burns lasting approximately 47 minutes each, with 2-hour intervals between burns. This wasn't a single course correction, this was a carefully orchestrated sequence of powered maneuvers. An orbital mechanics specialist described what the data shows. Atlas executed what we call a multi-burn trajectory modification. Each thrust burn adjusted velocity and direction incrementally, building toward the final course change. That's advanced spaceflight technique, exactly how we'd program a spacecraft to perform major trajectory modifications efficiently. The total velocity change, what space engineers call delta V, was approximately 8,000 miles per hour. To put that in perspective, that's more than the escape velocity needed to leave Earth entirely. Atlas just demonstrated it can generate thrust equivalent to launching from Earth's surface to interplanetary space while already moving at interstellar velocities. The energy requirements are mind-boggling. Conservative calculations suggest Atlas expended energy equivalent to the total power output of every nuclear reactor on Earth running continuously for 6 months, all in 18 hours of thrust burns. Whatever propulsion system Atlas uses, it operates at energy densities and efficiencies we can't even theoretically match. But it's not just the amount of thrust that's extraordinary, it's the precision. Atlas didn't just blast engines and hope for the best. The thrust burns were timed and calibrated to achieve a specific final trajectory with incredible accuracy. The resulting course takes Atlas exactly where it apparently wants to go, straight toward the Sun. Radio telescopes detected something else during the maneuver. Electromagnetic emissions from ATLAS spiked dramatically during each thrust burn. The signal characteristics match theoretical predictions for plasma exhaust from advanced ion drives or even antimatter propulsion systems. Whatever's pushing Atlas generates massive electromagnetic signatures as a byproduct. A propulsion engineer analyzing the emissions described them as extraordinary. The electromagnetic spectrum during thrust burns shows ionized particles accelerated to significant fractions of light speed. That's exhaust velocity approaching relativistic ranges. We can't build engines that do this. Atlas has propulsion technology decades, possibly centuries beyond our current capabilities. The trajectory change also required ATLAS to overcome its own momentum. Objects moving through space tend to stay on their current path unless acted upon by external forces. To change course as dramatically as Atlas did requires not just forward thrust, but the ability to redirect that thrust vectorially, pointing engines in precise directions to modify both speed and heading simultaneously. Atlas's new trajectory is what's really got scientists both fascinated and terrified. This isn't a gentle approach to the Sun's outer regions. This is a dive toward the solar interior that should be suicidal for any known object or technology. Current tracking data shows Atlas will reach what's called the chromosphere, the lower layer of the Sun's atmosphere, in approximately 12 days. The chromosphere sits just above the Sun's visible surface and has temperatures ranging from 6,000 to 20,000 degrees Celsius. That's hot enough to vaporize any spacecraft we've ever built in seconds. But Atlas's trajectory takes it even deeper. If the current course holds, Atlas will pass through the chromosphere and enter the Sun's photosphere, the layer we see as the Sun's surface. Temperatures there reach 5,500 degrees Celsius, and the density of solar material is thousands of times greater than anything in interplanetary space. An astrophysicist analyzing the trajectory described it as unprecedented. No spacecraft has ever ventured this close to the Sun. The Parker Solar Probe, our closest approach to date, reaches the outer corona but stays well away from the chromosphere. Atlas is heading into regions where we've never had direct observations because nothing survives there. The closest approach point, called perihelion, will bring Atlas to within approximately 500,000 miles of the Sun's center. That's roughly 200,000 miles closer than Mercury's orbit and deep into the Sun's lower atmosphere. At that distance, solar radiation intensity is about 500 times stronger than at Earth's distance. But here's what makes this even more alarming. ATLAS's trajectory shows it will slow down as it approaches the Sun. Normal objects accelerate as they fall toward massive bodies due to gravity. Atlas is apparently using thrust to brake its approach, which means it's not on a collision course. It's performing a controlled descent into the solar atmosphere. A trajectory analysis specialist explained the implications. When you brake approaching a massive object, you're either trying to achieve orbital insertion or you're planning to operate in that environment for an extended period. Atlas isn't just passing close to the Sun, it appears to be planning to stay there for a while. The approach angle is also significant. Atlas isn't diving straight toward the Sun's center. It's approaching at an angle that will take it through specific regions of the solar atmosphere, areas where solar activity is currently most intense. It's like Atlas calculated its approach to maximize exposure to active solar phenomena. Multiple space agencies are now redirecting solar observatories to track ATLAS's approach. The Solar Dynamics Observatory, SOHO, and other sun-watching spacecraft are being reprogrammed to focus on ATLAS's path. Scientists worldwide want to observe what happens when an object demonstrating impossible capabilities dives toward the Sun. The obvious question is, what could possibly be at the Sun that's worth this kind of risk? Several theories are emerging, each more extraordinary than the last. The most straightforward explanation is energy collection, but on a scale far beyond what we observed during ATLAS's previous corona passage. If Atlas can survive in the Sun's lower atmosphere for extended periods, it could harvest stellar energy directly from the densest regions of solar material. That would provide power reserves orders of magnitude greater than its previous refueling. A fusion energy researcher described the potential. The Sun's chromosphere and photosphere contain energy densities we can barely imagine. If Atlas has technology to tap into those regions directly, it could collect energy that would power advanced systems for years, decades, possibly longer. It's the ultimate refueling station. But there's a more speculative theory that some scientists find compelling. ATLAS might be attempting to communicate or interact with the Sun itself. Recent observations have shown the Sun has complex magnetic field structures, plasma dynamics, and behaviors we still don't fully understand. What if ATLAS is equipped to study or even influence solar processes? An astrophysicist raised the unsettling possibility: we think of the Sun as a giant fusion reactor, but it's also the most complex magnetic and plasma system in our solar system. If ATLAS has technology to manipulate magnetic fields at the scales we've seen, it might be able to interact with solar dynamics in ways we haven't considered. That's either incredible science or a potential weapon depending on how it's used. There's also a more alarming theory. ATLAS might be attempting to modify the Sun. Sounds like science fiction, but consider what we've observed. ATLAS has demonstrated technology far beyond ours. It's diving toward regions of the Sun where it could potentially affect solar processes. Even minor influences on solar dynamics could have massive effects on the entire solar system. A solar physicist explained the nightmare scenario. The Sun operates in a delicate balance: fusion rates, convection patterns, magnetic field cycles. If something could disrupt that balance even slightly, the effects would propagate throughout the solar system. Increased solar flares, altered solar wind, changes in radiation output, any of these could devastate Earth's technology infrastructure or even affect our climate. Another possibility is that ATLAS is looking for something at the Sun. Ancient data perhaps, or artifacts from previous visitors who might have used the Sun as a waypoint or storage location. The Sun's interior could theoretically preserve information or materials in ways we don't understand. But perhaps the most concerning theory is that ATLAS is testing itself, or testing us. By diving toward the Sun in such a dramatic fashion, ATLAS demonstrates capabilities that should be impossible, while also showing us it can navigate to the most powerful object in our solar system. That's either scientific exploration or a very clear demonstration of superiority. ATLAS's sudden course, change toward the Sun, has triggered emergency responses from space agencies worldwide, and the reactions reveal deep divisions about how to interpret this maneuver and what, if anything, should be done about it. NASA convened emergency sessions with international partners within hours of detecting the trajectory change. Classified briefings to government officials focused on scenarios ranging from scientific observation to potential threats to Earth if ATLAS's solar interaction goes wrong. A space agency official described the mood: there's genuine uncertainty about whether we're watching advanced scientific exploration or observing preparation for something that could affect the entire solar system. ATLAS demonstrated it can maneuver anywhere it wants. Now it's going to the Sun, the energy source that sustains all life on Earth. The implications are profound. China's space program released a public statement urging cautious monitoring and international coordination regarding ATLAS's solar approach. Russia's space agency echoed similar concerns. The European Space Agency activated emergency protocols for monitoring unusual solar activity that might result from ATLAS's presence in the solar atmosphere. But there's also significant debate about whether humanity should attempt any intervention. Some defense officials argue that if ATLAS poses any potential threat to solar stability, action should be taken before it reaches the Sun. Others argue that any hostile action against ATLAS could provoke exactly the response we're trying to prevent. A former military space commander described the debate: do we have the right to interfere with ATLAS's mission, whatever it is? Do we have the capability even if we wanted to? And most importantly, if ATLAS is approaching the Sun with specific objectives, should we risk antagonizing whatever intelligence controls it? Several nations are quietly mobilizing space-based assets to observe ATLAS's solar approach. Military satellites are being repositioned. Deep space tracking networks are focusing all available resources on monitoring ATLAS's trajectory. And contingency plans are being developed for scenarios where ATLAS's solar interaction produces unexpected effects. The scientific community is equally divided. Many researchers see ATLAS's solar dive as an unprecedented opportunity to observe advanced technology interacting with stellar processes. Others warn that encouraging or even passively observing could be tacit approval of actions that might prove harmful. A ethics researcher studying first contact scenarios described the dilemma. We're watching an intelligence we don't understand approach the energy source our entire civilization depends on. We don't know their objectives, we can't predict the outcomes, and we have minimal capability to influence events. That's one of the most vulnerable positions humanity has ever been in. As Atlas continues its approach toward the Sun, scientists are modeling possible scenarios for what might occur when it arrives, and the range of possibilities spans from fascinating to catastrophic. Best case scenario: Atlas conducts scientific observations and energy collection in the solar atmosphere, gathers data, and departs without significantly affecting solar processes. In this scenario, humanity gets a demonstration of technology that can survive stellar environments, potentially learning from observations of ATLAS's methods. A solar physicist described this possibility. If Atlas simply collects energy and observes solar dynamics, we learn that it's possible to operate in environments we considered completely off-limits. That knowledge alone would be revolutionary for future spacecraft design and solar exploration. Mid-range scenario: Atlas's presence in the solar atmosphere causes local disturbances, enhanced solar flares, altered magnetic field patterns, unusual coronal mass ejections. These wouldn't necessarily threaten Earth directly, but could affect satellites, communications, and space-based infrastructure. A space weather specialist explained, "The Sun is already dynamic and unpredictable. Adding an artificial object with powerful magnetic fields and energy systems could trigger enhanced solar activity. We'd need to prepare satellites and power grids for potentially stronger space weather than normal. Worst scenario, Atlas's interaction with the Sun triggers major solar events, powerful flares directed toward Earth, massive coronal mass ejections, or disruptions to the solar magnetic field cycle. These could damage satellites, disrupt global communications, harm astronauts in space, and potentially damage power grids on Earth's surface." But the nightmare scenario keeps appearing in classified briefings. What if ATLAS can actually influence solar output? Even a fraction of a % change in solar radiation reaching Earth would have climate implications. Increased output could cause warming. Decreased output could trigger cooling events. A climate scientist described the stakes. Our entire climate system is balanced around receiving a specific amount of solar energy. Small changes in that input cascade through weather patterns, ocean currents, and atmospheric chemistry. If Atlas could modify solar output by even 1%, the effects on Earth would be measurable and potentially severe. There's also the possibility that ATLAS's solar interaction is preparatory, that it's establishing capabilities or infrastructure at the Sun for future operations. If Atlas can survive in the solar atmosphere, it could potentially station itself there permanently, monitoring Earth from the ultimate vantage point. An aerospace strategist raised another concern. If Atlas establishes a presence at the Sun, it controls the high ground of the entire solar system. Everything else orbits around the Sun. An intelligence positioned there could monitor all inner planets, intercept communications, and potentially influence solar processes. That's the ultimate strategic position. With approximately 12 days until Atlas reaches the Sun's chromosphere, every day brings new observations that refine our understanding of what's about to happen. And the data is both fascinating and increasingly alarming. Atlas continues its deceleration burns, gradually reducing its approach velocity. Current calculations show it will enter the chromosphere at roughly 50,000 miles per hour, fast enough to maintain momentum against solar plasma, but slow enough to operate in that environment for extended periods. The electromagnetic transmissions from ATLAS have changed character as it approaches the Sun. Early broadcasts appeared exploratory. Current transmissions show patterns consistent with active sensor scanning. Atlas is apparently mapping the solar atmosphere in real time, gathering data about conditions it's about to enter. A signals intelligence specialist analyzing the transmissions described them as purposeful. Atlas is conducting reconnaissance of the solar environment ahead of its arrival. The transmission patterns suggest it's measuring temperature gradients, magnetic field strengths, plasma densities, and radiation levels. It's gathering the data needed for safe navigation in an extreme environment. Multiple observatories have detected ATLAS, deploying additional smaller objects during its approach. These objects aren't following Atlas toward the Sun. They're taking up positions in orbit around the Sun at various distances, creating what looks like a monitoring network. A space surveillance analyst described the deployment pattern. Atlas is positioning assets to observe its own solar interaction from multiple angles. These could be cameras, sensors, or communication relays. Whatever Atlas does at the Sun, it wants to record and possibly transmit data about the event. The objects Atlas previously deployed near Earth have also changed their behavior. They're now transmitting more frequently and appear to be coordinating with ATLAS's approach to the Sun. It's as if Atlas is preparing a network to witness and document what happens at the Sun, then relay that information elsewhere, possibly back to Earth or to other locations in space. Recent spectroscopic analysis of ATLAS shows its surface characteristics are changing as it approaches the Sun. The object appears to be reconfiguring itself, possibly adjusting thermal protection systems or repositioning components in preparation for entry into the solar atmosphere. A materials scientist studying the observations described it as adaptive. Atlas isn't passively approaching the Sun. It's actively preparing for solar immersion, modifying surface properties, possibly adjusting magnetic shielding, preparing systems for extreme conditions. That's sophisticated environmental adaptation in real time. The countdown embedded in Atlas's transmissions, the numerical sequence that's been decreasing throughout its journey through our solar system, is approaching a critical point. Current analysis suggests the countdown reaches 0 approximately when ATLAS achieves its deepest penetration into the solar atmosphere. While Atlas heads toward the Sun, the implications for Earth are becoming increasingly clear. And regardless of Atlas's intentions, its solar interaction will affect humanity in multiple ways. First, there's the space weather concern. If Atlas triggers enhanced solar activity, Earth's technology infrastructure faces potential damage. Communications satellites could be knocked offline. GPS systems might experience disruptions. Power grids could face surge events. The economic cost of major space weather events runs into trillions of dollars. Emergency management agencies worldwide are quietly preparing contingency plans. Power companies are being briefed on potential grid protection measures. Satellite operators are developing strategies to safeguard spacecraft if solar activity spikes. Nobody wants to alarm the public, but serious preparations are underway. But beyond immediate space weather concerns, there's the question of what Atlas's solar capabilities mean for Earth's long-term security. If Atlas can operate in the Sun's atmosphere, it has access to effectively unlimited energy. If it can influence solar processes, it could theoretically affect Earth's climate, disrupt our technology, or demonstrate capabilities that make human civilization vulnerable. A strategic security analyst described the dilemma. Atlas has just demonstrated it can navigate to the most powerful and important object in our solar system, the Sun that sustains all life on Earth. Whether its intentions are peaceful or not, that capability alone represents a fundamental shift in the strategic balance. We're no longer the only intelligence that can potentially affect conditions in our solar system. There's also the profound psychological impact of watching Atlas dive toward the Sun. For months, we've tracked this mysterious object through the solar system. Now, it's approaching the center of everything: the star we orbit, the source of our energy, the focus of countless cultures and religions throughout human history. Atlas's interaction with the Sun carries symbolic weight beyond just scientific or strategic implications. But perhaps most importantly, ATLAS's solar approach might reveal its ultimate nature and intentions. The Sun is the ultimate test. If Atlas survives extended exposure to stellar conditions, it proves technology capabilities beyond anything we've imagined. If it emerges from the Sun with enhanced power and new capabilities, it demonstrates a level of sophistication that should humble us. And when Atlas eventually leaves the Sun because the trajectory suggests it will survive and depart, where will it go next? Back toward Earth with enhanced capabilities? Toward the outer solar system? Out of our solar system entirely? Atlas's post-solar trajectory will tell us whether its solar mission was preparation for further operations in our neighborhood or a final refueling before departure. Right now, Atlas is 12 days away from diving into the Sun's atmosphere. Every hour brings it closer to the most extreme environment accessible in our solar system, and every day reveals new aspects of this object's extraordinary capabilities. The trajectory change proved ATLAS can maneuver anywhere it wants. The approach velocity shows it can control its speed with precision. The preparation we're observing proves it's capable of adapting to environmental challenges. Whatever Atlas is, it represents technology operating at levels we struggle to comprehend. In 12 days, we'll watch as Atlas enters the Sun's chromosphere. We'll observe whether it survives conditions that should vaporize any known material. We'll see if it can operate in an environment where temperatures exceed 20,000 degrees and plasma density crushes spacecraft. And we'll learn what happens when artificial intelligence meets stellar processes. The Sun has been the center of human existence since our species emerged. Every civilization has revered it, studied it, built societies around its rhythms. Now, an intelligence from beyond our solar system is approaching it with purposes we can only guess at and capabilities we cannot match. Atlas changed direction. It's diving toward the Sun, and in 12 days, we'll discover what happens when the impossible meets the untouchable. What do you think Atlas is really trying to accomplish at the Sun? Energy collection, scientific research, or something more alarming? And what do you think will happen when it arrives? Share your thoughts below and make sure you're subscribed, because when Atlas reaches the Sun in 12 days, we'll all witness together whether this is the most amazing scientific event in history or the beginning of something far more concerning.